All right, we should be live. Hopefully this thing is on. I'm David. I'm a developer advocate here at Balena, and today we're gonna talk about how you can help fight COVID-19 using a Raspberry Pi to crunch data and fold protein. I'm gonna walk you through the whole project. It's pretty easy, and we're certainly said, I'm a developer advocate at Balena. Now, most people, when they think of Balena, actually are more familiar with this, Etcher. So if you've ever used Etcher to flash an SD card or write a USB stick with, an operating system like Linux, you've seen our product then. So hang on, just need to get that out of the way, and there we go. Okay, so we build a lot of cool projects. We have a team of hardware hackers that build our projects that are geared towards our IoT fleet managers to kind of show off the capabilities of what the Balena platform can do. As I mentioned, it's all about fleet management and connected devices at scale. So you can update your devices. You can push containers over the air to your devices, no matter where they're at. So, having one Raspberry Pi on your desk is all well and good. But once you get tens, hundreds, thousands of devices, you need a way to securely manage those. So that's what Balena is all about. With that said, though, actually for today, I'm going to show you our COVID-19 project called Fold for COVID. So as the current situation kind of took shape, I was looking on social media and I noticed a lot of people are doing 3D printing for PPE projects. Some people have the ability to build ventilators. I saw a lot of ventilator projects and thought to myself, well, I don't actually have a 3D printer or know how to use one. I certainly don't know how to build a ventilator. But one of the other things that I had seen some folks doing was folding at home. And folding at home is this essentially distributed computing project where you lend your computer's processor or GPU to scientists who are running simulations. Okay, so I thought, oh, that's all well and good. I can certainly do that. I have one laptop and I set it up and it seemed pretty easy. And I thought, okay, well, I work for Balena, which is an IoT fleet management company. I happen to have lots and lots of single board computers and other types of devices. I have Raspberry Pis, I have a Jetson Nano, I've got other odds and ends. Let's see if I can run it on those. And so, long story short, turns out you actually did not used to be able to run these kinds of projects on the types of processors that are on these. So that are on single board computers. So I reached out to some peers in the community and started a conversation with some folks here at the Rosetta at Home project. The Rosetta at Home project is run by the University of Washington. And like Folding at Home, they have a team of scientists, medical researchers, that use the BOINC platform, which is, again, distributed computing, to essentially look for proteins that will bind to the spike on the COVID-19 coronavirus molecule. Now, certainly, I'm not a doctor. I don't know the exact mechanics of how it works. Certainly feel free to read up on it. But ultimately, what it comes down to is doctors are looking for a protein that will cover up the spike on the coronavirus molecule so that it cannot penetrate healthy cells. Now, all of the work that this team is doing, again, the University of Washington Baker Lab is where this project is housed, is on the treatment side of the equation. So they're not necessarily looking for ways to vaccinate, but more on the minimize the effects once a patient has already contracted the virus. So with that said, I want to give a quick moment. I saw some folks getting joined in still, actually, so hang on. There we go. All right, so as I had mentioned, we reached out to this team and asked, hey, what would it take to enable Raspberry Pis and other single board computers to sort of join in? And they pointed us to the source code. It's open source. It's under an academic license, again, being that it's housed at a university. And so myself and a few members of the community took a look at it. Wasn't all that difficult to really port from x86 to ARM processors. And we were able to get it up and running and compiling in a matter of, I don't know, a week or two. We then worked with the team at the university to have it brought into their main build system. Once that occurred, we're able to start actually crunching data, folding proteins on our Pis and Jetson Nanos. A couple of weeks of testing there to validate the results and verify that the science being done was in fact actually valid, which proved successful, led to the Rosetta project deploying it live. So now, as I'm going to show you in a moment, you can actually do protein folding on your Pis and your Jetson Nanos. So let me switch cameras real quick. Stop the screen share and then come over here, switch to this camera. You see my desk full of parts, and I see yet again that it's out of focus. I apologize. Hey, I see Matthew has joined. Thanks, Matt, for joining. So as I mentioned, Balena has a team of hardware hackers that build cool projects, and I'm typically tasked with showing off those cool projects. So I have quite a bit of gear of my own in order to duplicate their setups. So I have on my desk, I'm going to move a few of these out of frame that are not really going to be relevant, but as you can see, I've got lots and lots of single board computers, and that was, again, sort of the impetus for wanting to get this project running on ARM-powered devices. Let's get that out of the way as well. I'll switch back for one more moment to the main camera. All right. So you can see I've got all my parts laid out in front of me. I'm going to turn my screen share back on one more time. And come back around full circle to the Fold for COVID website. So in the process of getting the software ported to ARM, and the Rosetta at Home project functioning, we validated the results on Ubuntu. Ubuntu has a native 64-bit build for ARM processors, for the Raspberry Pi, I should say. And we used that for testing. And once that looked good and everything was validated there, we went through the process of putting it all into a Docker container. Now, the traditional Balena workflow is not terribly difficult. That's the whole point of the fleet management platform, is to sort of reduce friction for fleet owners, but you still definitely need to have some technical understanding. So in the past, after we got all of the containers built and running, we went through the traditional Balena workflow, which is install the Balena CLI tooling on your laptop, open up a Balena Cloud account. It's free for up to 10 devices. Do a git clone on the repository containing the containers, and then Balena pushing that over the air to your target device. Now, ultimately, that's really only about 4 or 5 commands, but you still certainly need to know what you're doing. You need to understand how to operate a Linux terminal and install packages, and then the Pi will download over the air. And, you know, it's not rocket science, but there is a barrier to entry. So we thought, how can we make this even easier? And the way to do that was to pre-populate the containers into an SD card image and allow for injecting a set of Wi-Fi credentials for a user to then simply download and flash an image, power on their Pi, and begin crunching. So after a few more weeks of effort, we got that all built out and we launched this site here, foldforcovid.io. Let me drop that link into the YouTube chat. And now that oops, not sure what that is. That is string of letters and numbers. Okay, let's try that again. Grab, oops, missed back. There we go. All right, URL is in. So now that we've got the site built out and all of the underpinnings in place, users can come here and just simply choose a device. I'm going to select a Raspberry Pi 4 because that's what I'm going to be using in this demo. Choose your connection, whether you're going to use Ethernet or Wi-Fi plus Ethernet. I'm going to use Wi-Fi. I'm going to enter my Wi-Fi credentials here. I made sure to set up a temporary access point because I know Phil is going to be watching and he always tries to take my credentials and get on my network. So good luck with that, Phil. Drop that in and download the OS. Now, we are not saving your Wi-Fi credentials. We're not storing them anywhere. We're simply taking that input, passing it through to a pre-made image, and then presenting the image to be downloaded, as you can see there in my browser. All right, so I've got it downloaded. Pretty simple. Step 2 is download and install Etcher. Now, I showed you I already have Etcher installed, so I did skip a step there, but I'm ready to grab an SD card that I had in my collection here that you saw on that other camera shot earlier, and pop that into the reader. Choose an image that I just downloaded right there. Yep, Balena Cloud, Rosetta Home, Pi 4, and flash it. Now, that's going to take a few minutes. I have a notoriously slow SD card reader, so I'm going to turn off my screen share and come back to my other camera angle because we're going to talk about the hardware a little bit more in detail. So let's go back to my blurry camera and get some more of these parts out of the way. And as I mentioned, we are about to be doing some data crunching, some protein folding. It is very CPU intensive. So a Pi 4 runs hot enough as is. I'm going to actually put a heat sink on it And I've also got a little fan here that I'm going to use as well. This is just a little cheap fan, but it'll do the job, and it goes on to pins 4 and 6 if I remember correctly. I sure hope I've got that right. You can also use this hat that I've got here that allows for powering the Pi over a barrel jack. You can see that on there. And it has a fan built in. The nice thing I like about this is it's got an on-off switch, a proper switch there. So that's convenient as well, but I'm not going to use that for the moment. I'm just going to go standard. Etcher's still flashing over on my other monitor, so I'm going to give that a little bit more time. And for you Jetson Nano folks out there, I'm going to talk about this for a moment while that flash finishes up. The Jetson Nano can run off of a micro USB port to sort of like a cell phone charger. However, that's only, I want to say 0.5 amps, if I remember, if I've got my terminology right. It's 5 volt up to 1.5 amps. I can't remember. Either way, it's not going to provide enough power. So what you actually need is a little jumper that goes onto the Jetson Nano over here. And I've also bought a fan for the Nano as well, which gets attached over here on the fan header pins. And something like this. Let me see if I can get this in frame. Let's hope it's not reversed, but this is an Adafruit 5 volt, 4 amp power adapter. So this will be good for up to 20 watts. And it's got the barrel jack on it here. And you connect in on this side. And now you've got enough power to do some serious crunching. So Nano users, keep in mind, you need a stronger power supply. Don't forget your little jumper as well. All right, let me get that back out of the way. And Etcher did in fact complete. So grab that SD card out of the laptop. Put it in to our Pi. And power up. While that's booting, I'm going to make one additional note, which is a Jetson Nano does not actually have onboard Wi-Fi. So you need to use a little USB Wi-Fi dongle if you want to go wireless. Otherwise, you'll need to use Ethernet. That's the only built-in connectivity on it. All right, so now looks like our Pi is powering up. Let me get Etcher out of the way. And our next talking point here, I'm going to bring my screen share back on now that we simply have a blurry Pi in front of everybody. And back to our Fold for COVID website. Okay, so we've got the card inserted, as you can see. And next is power up. The neat thing about the project is because everything is pre-populated, we get a URL foldforcovid.local that is generated by the Pi. My router does not always respect MDNS, but I think it should be okay. Otherwise, I'm going to have to query the router and find the IP address. But let's take a quick glance and see if it's coming online. Actually, looks like it is. So I have one that's already running, just in case this didn't work. And since it was the first one to join, it already took foldforcovid.local. But what I can do, then I just glanced at my router and noticed that, oops, http:// my router assigned a -4 to it. Now let's see if it will respect .local. It's not going to respect that. Let's try this. Nope, it's not liking it. Well, sure, I'm glad I had that one already prepared, but let me go grab the IP address of the one that I just provisioned, and we will go via its IP. But like I say, if you only have one device, you will be automatically assigned to, as you can see here, fold for COVID.local. In this particular case, though, I'm going to use the IP. Oops. And let's see if that works any better. No such luck. Oh, there it goes. Just taking a moment. I have to wonder if the Pi is still doing something. Oh, actually, yes, it sure is. Okay, so as you can see, all I did was flash the SD card, pop it in, and power on the Pi. Automatically, it has attached to the Rosetta Home project. It's now downloading work units, and it'll start getting ready to crunch these in just a moment. This interface, it's certainly not the most user-friendly, but it gives all the relevant information. So what you can see on here is that it's got 5 jobs that it is currently downloading. That's the state column. They're all associated to the Rosetta at Home project. Estimate is 8 hours. It's going to take the Pi about 8 hours to actually fold the protein. This is not a fast process. These things are complex, multiple gigabytes in size. When you're doing protein simulation, it takes time. And it looks like 3 of them are running and 2 of them are now waiting in the queue. So, and you can see that the task names over on the right-hand side are the particular jobs themselves. So with that said, I want to talk a little bit more about the technical details. So I just used a Raspberry Pi 4 with 4 gigs of memory. As I mentioned a moment ago, these things are large simulations. On occasion, the researchers have loaded up the work queue with some smaller jobs, but the bulk of them require about 2 gigs of memory. So the Jetson Nano has 4 gigs of RAM, no problem there. The Raspberry Pi 4, you can get in 1, 2, or 4 gig variants. The 2 gig or the 4 gig variants will give you a relatively endless supply of work units. You can keep those things folding pretty much all day long. A Raspberry Pi 3B, 3B Plus, or a Raspberry Pi 4 with 1 gig of memory, many times will sit idle and will simply keep checking in to the Rosetta project to see if there's any jobs available. If there happen to be some in the queue, it'll grab them and start crunching, no problem. Once it's done, it'll automatically upload it back to, I just realized I have the camera on the Pi. Let me switch that back to myself. Once it's done, it'll automatically upload them to the Rosetta project. And if there's more available, it'll grab some more tasks. So anyways, the point is this. If you have a 3B, 3B Plus, or a 1 gig of memory Pi 4, it's best to just leave it running. Periodically, it'll have jobs. Other times, it will not have jobs. But the 2 gig and the 4 gig variants pretty much run round the clock. So as you can see, these started crunching. They're only 0.2% of the way, but you are now folding protein as we speak right here on my desk on a Pi. So it's a pretty cool project. Now, let me come back to the site. And, we have some links for Twitter and Facebook, of course, and LinkedIn, but I want to come back up. So 5,651 users have joined. You can actually run the project on x86 devices. If you have a spare laptop, you can run it on there. You can, use your home PC as well, but just keep in mind that this process here that I just demonstrated is geared towards essentially wiping the hard drive. So we're talking here about literally spare computer. There are other methods to just simply add a BOINC client to your PC or laptop and, maintain your existing setup and go through that process, but it's not what I wanted to focus on today. Let me just take a quick peek at YouTube chat. Hey, Matthew. Let's see. Yep, you were wondering how MDNS. Let's see. I expect that's done with some Yocto. Yes, correct. It's part of the OS. And GOTTY is the project, the utility we're using to pass through to the web interface. You're correct. So I think that about covers everything from the build perspective and the technical perspective. One quick shout out for our forums. If you run into any trouble, if you end up building it, let us know over here on the forums. I'll drop this link in. We have a category strictly devoted to the Fold for COVID project. There you go. There's some cool pictures of some builds that are in here. Some folks have got some pretty elaborate setups. It's really, really neat to see some of the community users. And then the last thing I want to cover is this. When we first started, some folks had asked, well, it's only a Raspberry Pi. It's not the same thing as my Core i7 with, an Nvidia GTX 2080. And we get that. Totally understand. But you know what? There's power in the sheer number and the volume of these Pis that are in the fleet, and Nanos as well. And there's a few others, TX2s and a couple other devices. But every little bit helps, right? So this Rosetta Home website that I showed earlier also keeps track of the top teams. You get ranked by your average credits that are accumulated. And so the Fold for COVID project is currently ranked 18th in the world, with over 1 million credits being computed each day, top 1% of all teams worldwide. So it's actually really, really impactful. People in the beginning thought, oh, it's just a Pi. What's it going to do? Well, you're right. One Pi doesn't necessarily make a difference, but thousands of them absolutely do. So by all means, if you have some Pis or Nanos or other devices sitting around that, that are not being used, that are just collecting dust, please, we encourage you to join the fold. That's it for me. Looking at the clock, this talk was originally designed for a 30-minute time slot. It got pushed to a 1-hour time slot, but I saw that I overlapped with one other really cool maker here, this Sophie Wong project with the studio tour and works in progress. So I ended up keeping this session at 30 minutes so that folks could hop over to that one as well, because I noticed after Maker Faire had dedicated this one to an hour, it overlapped with that session, and I didn't want folks to have to miss that. So looks like I've timed it just about right. I'll go ahead and end the stream and wrap it up. By all means, if you end up building the project, please let us know. You can find us on Twitter or over on those forums. And thanks, everyone. Appreciate it. Have a good night.